So fun fact, so I'd already made this video, which is why like the notes are already up, but like it didn't record my voice and I didn't think anyone wanted to look at this without audio, so here we go, right? Okay, so for this module, right, we're talking about steps for significance tests. And the reason why this is important is because this is a key tool for statistical inference. Mainly because, like as researchers and social scientists, we tend to make guesses about a population parameter, about what's exactly true or not. So we may say something like 75% of people prefer Coke over Pepsi, or 63% of people prefer bland food over spicy food, or that the average person gets speeding tickets, 6 speeding tickets in their lifetime. Basically, all of these are statements about the effect of what happens in the population. Sometimes these are proportions, sometimes these are means, sometimes they're not anything else. So what we try to do as a researcher or social scientist is to test statements, right? And so we try to do this by proposing that there are different values that are far and away guesses, right? And we do this through significance tests. So one way to do this, right, is that, let's say, for example, if we believe that people prefer Coke over Pepsi, 75%, we might say we collected data and we found it was actually 62%. If we were interested in people who were preferring bland food over spicy food, so 63%, maybe we'd say it's actually 47%. If we believe that the average person gets 6 speeding tickets in a lifetime, we might say, after collecting data, it's actually 10 based off of that. So the goal then, right, is what we try to do though, is we try to figure out, are these values actually different from like what the population parameter is? Are they statistically different? And so is there a meaningful effect? With respect to what we try to do, we do collect categorical data, and we are looking at proportions, and if we look at quantitative data, we look at differences across averages. The way that we usually state these, though, is through a null and alternative hypothesis notation. So this HO is a null hypothesis, right? And so there's a statement that the population parameter is some value. So in that first example, it would be, 0.75 is the value for people who prefer Coke over Pepsi. The alternative hypothesis, based on data, is saying that it's actually a different value. It's either less than or more than. And so in this example that I have here, so we might say what a common one that happened in research studies, right, is that the effect of low self-control on crime is actually 0. And the alternative might be, say, that we assert that low self-control leads to 3 or more crimes. So the way that we usually do this is to collect data in a survey. We calculate a mean or proportion, depending on what we're doing. And then we see if the collected data are actually different than a population parameter. And the way that we determine this value is through like a p-value, which is a probability summary of whether the alternative hypothesis is actually different than the null. More often than not, if we're looking for statistical significance, we want to look for p-values that are less than 0.05. So a 1 in 20 chance, right? That this is not due to random chance alone, that we are observing a real effect. So this may sound a little bit convoluted, but hopefully in the next video, like the examples and videos will help clarify some of these points.